Good morning, afternoon, or evening. How you doing today? Welcome back to Mr. Moore's algebra class. And today we are going to continue with functions, and we're going to actually talk about relations, actually, and how relations can sometimes form scatter plots. And we're also going to talk about something called trend lines. All right. Now, a scatter plot is a relation which, when graphed, shows a possible relationship or correlation. A scatter plot is basically a relation, which a relation is any set of ordered pairs. A relation, remember, does not have to have a set formula or equation. That's what a function is. A function will never give you a scatter plot like this, because remember that you can only have one y for any given x. So a scatter plot is always going to be a relation. It's not a function. It is not attached to an equation. Now, what kind of correlations can you have when you have a scatter plot? Well, I gave you some pretty good real-life examples here. The thing about this, if you look at the way the points on this first graph over here are, okay, we have foreclosures and we have household units, okay? Foreclosures are when people can't pay their mortgage, they lose their house. And then if you lose your house, doesn't that create another house on the market for someone to buy? Okay, so that's what we're looking at here. So basically here, if you think about this, as foreclosures increase, okay, so do the number of household units that are available. As foreclosures increase, so do households that are available. So this is what's called a positive relationship. And a positive relationship or a positive correlation, both sets of data increase. So when you have a positive relationship, both the x and the y increase. The popular question here is, what's the independent variable and what's the dependent variable? It doesn't really matter. You can choose any one because you don't have a set function, okay? And by that, think about what we've talked about. Let's look at this data cluster. Let's look at this data cluster right here. Look, okay? Let's look at this guy right here. If you look at this right here, at this particular x, okay, you have several different red dots there. Okay, sorry about that. So if you look at this graph here clearly, at one x you have several different red dots, you have several different y's. So again, this is not a function. You don't have per se an independent or dependent variable. You just have a set, a domain, because you do have x values, and you do have a range, because you do have y values, but it's not a set equation. But a positive correlation, it's going to look like this. Both sets of values increase. And when you have a scatter plot like this black line here in the center, that's called the trend line. The trend line is basically an estimate of what's going on more or less. And if you look at this trend line, roughly, okay, it's not exact, but roughly, there's about the same number of points above the trend line as there are below the trend line. It's not an exact thing. It's an estimate, but you're looking for what we had just said, about the same on both the top and on the bottom, okay? If I have a trend line like this, does that really represent the data? No, because everything is below the trend line. You see what I'm saying? Okay. Negative relationship or negative correlation. We have the unemployment rate and the percent of college educated. Basically what happens here, as the unemployment rate increases, the college percentage educated decreases. What does that mean? The more people that are unemployed, that means more people did not go to college. Okay? This is a negative relationship. So what happens in a negative correlation or a negative relationship is that both sets of data, I'm sorry here, that's wrong, are decreasing. Okay, they decrease. In a negative correlation, both sets of data decrease. Okay, it's an opposite. It's an opposite reaction. And actually, you know what? That's completely wrong. Because look at what's happening here. I'm sorry, guys. I did this last night late. As this is increasing, what's happened to the y? It's decreasing. So in a negative correlation, as one variable increases, the other decreases. I'm sorry. It's kind of like working out and your fat content. The more you work out, the less you weigh. That's a negative correlation. So I'm sorry about that. Negative correlation. As one set of data increases, the other decreases. Yes, sir. Yes. Now, the last one that we see here is a no relationship. This is a no correlation. And a no correlation is basically a no correlation because there's no relationship between the data sets. If you look at this data set, you have the percent of people college educated and those that are pet owners. In order to be a pet owner, do you have to have a college degree? And do you have to have a college degree in order to be a pet owner? So does that have any relationship at all? No. So that's a no relationship or no correlation. So again, positive, as one increases, the other increases, or as one decreases, the other decreases. They both do the same thing. In a negative relationship, as one increases, the other decreases. And in a no correlation, nothing's happening because there is no relationship. There is no correlation at all. Okay, does that make sense? All right. May I continue? Okay. Let's do this. Okay. So for example, let's learn how to create a scatter plot because it's really easy. The table below shows the number of species added to the list of endangered and threatened species in the United States during the given years. Graph a scatter plot and determine the type of correlation, if any. Okay, please pay attention to the notes right now, okay? Actually, let me go ahead and slim this down so we can look at the table while... Okay. Okay. Let's go ahead. And, okay. So we have right here. Now we can do this. Move this down. Okay. So, when we are making a scatter plot, actually, let me go ahead and move this even more down because I want you to see everything that we do here. Okay. Okay. When we are making a scatter plot, the first thing we have to do is write the title. So the title of this is increase in the list, right? Because there's an increase in the list. They label the table for you. So go ahead and label your graph. Species added to the list. That's the title of this scatter plot. If you do not have a title, I cannot understand what you're trying to show me, and I cannot give you credit for that. Okay? Please be aware of that. Now we have two different categories here, or variables. We have calendar year and species. I like to always call year or time X. So those are going to be my X values. Species are going to be my Y values. Okay? So I got to, again, label. X is my year. So I put year, bless you. And Y is the species. So I put species. Is everyone with me so far? Yes? Okay. Now, as far as labeling, you have to pay attention to how you label things. They go from 1996 to 2002. You could go by any intervals you want, but in this case, it's just easier just to go by intervals of 1. So I'm going to show you something called a line break. Because you see how we're starting at 1996, right? And then we're going by intervals of 1, correct, guys? Okay, so technically, we would have to start at year 0 and go 1, 2, 3, all the way to 1996. Or you can do this. It's called a line break, okay? And a line break lets the reader know, hey, reader, look, I'm going by intervals of 1, but I'm starting at this value. That allows you to do that. So you have a line break here, and that's going to be your 1996. This is my 0, okay? You have your line break, that's going to be your 1996. And then from there, I'm just going to go, every interval is going to be 1 year. Let me clean this up, though. This is your 0, and right here, that's your line break. So that's 1996, 1997, 98, 99, 100, 2000, 2001, and 2002, correct? Okay. So I have a little label here from 96 to 2002. Now, on my Y's, my species, okay? My species, I go from all the way from 9 to 91. So what intervals do you guys want to use there? Well, I go from 9 to 91. So what intervals would you like to use? 9s? 9s don't. I mean, 10s would be probably better. I don't need a line break because I'm starting at 10 and I'm going by intervals of 10. You don't need a line break unless you're going by different intervals than your first value. If you're going by 2s and you go 2, 4, 6, 8, you don't need a line break. But if you're going by 2s and you start at 100, you need a line break, then you put your 100, then 102, 104, 106. Does that make sense, guys, the line break? Okay, so we're going to go by 10s here. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And we're going to do some estimates. So, okay, guys, you read to me the values. Starting with 1996. 96, 91. So in 1996, we had about 91 endangered species. Okay? Next. Next. 97, 79. Okay, next. 98, 62. 99, 11. 2000, 2039. 2001, 2002. Okay, there we go. That's my scatter plot. Very simple. Are some of these estimated? Yes, estimates are allowed in scatter plots. What kind of a trend is this, or correlation? It's negative. As the years are increasing, what's happening to the Y's? They're decreasing. So as one increases, the other decreases. This is a negative correlation. No, you do not connect the dots. Now, if I wanted to make a trend line, which is an average, the trend line would roughly be, I'd say the trend line would probably be about here, about there. Real close to that line, but you have a couple over here, so you want a couple above as well. So that would be the trend line. But the question, do I connect the dots? No, you do not. Does that make sense so far? Labeling, you got labeling. You understand line break? You promise? Again, if I have my X and Y, let's say this is my X and Y axis, and I'm starting with intervals of 5, I do not need a line break. I do not. I'm going by intervals of 5 and I'm starting with 5. However, if I'm going by 5s and I'm starting with 50, I can't just do that. In that case, I need a line break. And then I would start at my 50 and then I could go by 5s. Okay? So I don't need a line break unless my starting value is different than my intervals. You with me? Okay, brothers, let's do this. Describe the correlation illustrated by each scatter plot. I have the hours of study and the Regents score. Regents is a test. In this case, the trend line would probably be more or less going like this. So what's happening here? As hours of study are increasing, what's happening? Positive correlation. Very good. Positive correlation. Excellent. How about this one? This just says the eruptive products of 1915 eruption at Lassen Peak. That's in California. This is silicon oxide, and this is aluminum oxide. What's happening here? As the silicon oxide is increasing, what's happening to the aluminum oxide? It's decreasing. So what kind of this is a negative correlation. Very good. If I wanted a trend line, it'd probably be roughly about here. That's about the middle of the data set. Does that make sense, guys? Okay. Next, I've got temperature and money. I'm assuming that this is probably electricity charges. So as the temperature here increases, what's happening to the cost? It increases. Where could this be modeled? What is this a good example of? As temperatures increasing? Miami, very good. As temperatures increase in the summer, I'm sorry, but your FPL bill is going to go way up. Okay? Your electricity goes up because you're using more AC. Very good. So what kind of a correlation is this, gentlemen? That's a positive correlation, absolutely. And then here, for the last one, we've got math and verbal on an SAT score. If you do well on math, do you necessarily have to do well on verbal? If you do well on verbal, do you have to necessarily do well on math? So what kind of a correlation is this? No correlation. Very good. There is no trend line here because it's just a mass. It's not really going up or down. It's just a mass of points. And they don't have any correlation. Does that make sense? Okay. Yes? I'm sorry, my man? The trend line for number 3. Thank you for asking. It'd be the trend line. How I like to look at it is I always look at the first point and then I look at the last point and I kind of try to connect the dots going through the middle. So that would be the trend line. No, thank you, son. All right, may I continue? Awesome. Identify a correlation you would expect to see between each pair of data sets. Okay. What did I tell you? The number of empty seats in a classroom and the number of students seated in the classroom.
No correlation.
No, there is a correlation for sure. Draw it out, guys. Draw it out. Okay, what do you want to call your x-axis? Number of students? The number of students seated, right? Students seated. Okay. And what do you want to call the y-axis? The empty seats. So I'll put empty. Okay, think about this, guys. Think about this room. How many empty seats are there after everyone has filled in the classroom? None. So as the number of students increase, what's happening to the number of empty seats? They're decreasing. So that's going to be a negative correlation. Are you guys seeing this? Draw it out sometimes. It's not easy for me to see everything just in my head. Sometimes I have to draw it out. Number 2, the number of pets a person owns and the number of books that person read last year. No correlation. Very good. That is random. That's what a correlation is. It's just random. It's like me saying the color of your hair and the amount of money in your pocket. What does that have to do with anything? Sir. It's not a matter of common sense. I think everything is common sense here. But yeah, you got to think about it. Is there a correlation? Is one affecting the other? If I tell you height of a mountain and temperature, what would that be? What kind of a correlation is? As you go higher and higher in the mountain, what happens to the temperature? It starts dropping. So what kind of a correlation is that? Negative correlation. You got to think about this. How about this one? The monthly rainfall and the depth of water in a reservoir. A reservoir is what keeps the rainwater. What would that be? Positive, absolutely. Positive correlation. Think about it. If you got the rainfall here and you got the reservoir here. As it rains, the reservoir starts to increase. Just the way it goes. Think about puddles on the street. When it rains, the puddles created. When it doesn't rain, the puddles dry out. How about the temperature in Houston and the number of cars sold in Boston? No correlation. None at all. How about the number of times you sharpen your pencil and the length of your pencil? Very good. Negative. Because every time you sharpen your pencil, you lose a little bit more. So the more you sharpen, the more you lose. Yes, sir.
So anytime does it make sense?
Okay, I don't want to say that. Anytime it doesn't make sense. I don't like to teach it that way. I like to think of it anytime there is no relationship between the two variables. I think that's a better way to teach it. Thank you, sir. May I continue, gentlemen? Okay, now the trend line. Let's get a little bit more specific on the trend line. The trend line is the line drawn on a scatter plot which helps show the correlation more clearly. It is also helpful when making predictions based on the data. Let's say that you have the temperature in Celsius, and then again, the prices, okay? As the temperature is increasing, your prices are increasing. Now, let's say that we have this graph for 26. But what if I know that as the summer goes on, I'm going to have 28, 30, 32, okay? I want to make a prediction. Well, since I made this trend line does keep going at that same angle, doesn't it? So at 32 degrees Celsius, I can link that up to a cost. I can bring that cost over this way, and roughly, we're talking, this is probably 8, and this would probably be like 1,000. So yeah, this would be roughly about, I don't know, 950, between 9 and 950. Is it exact? No. If you're planning a budget, is it good to have an idea? Yes. If you own a business, don't you want to know what your bills are going to be ahead of time to make sure you can pay those bills? Does that make sense, gentlemen? So these are the kind of things that business owners have to think about. There's a trend all year long. Let's follow that trend so I can make a budget. Does that make sense, guys, in making predictions? Okay. May I continue? Thank you. Okay, back here. This here is the investment to GDP. GDP is the gross domestic product. That is all of the money or monies that the United States of America gets through importing or taxes or exporting or creation or development projects, research projects. All of the money that comes in is called the GDP, gross domestic product. That is what we're worth, pretty much. And here we have an unemployment rate. Okay? As the investment in GDP goes up, unemployment rate goes down. Because if we have an investment in GDP, that means there's more money to create more jobs, less unemployment. Are you guys seeing the patterns here? Okay? So, the trend line here, roughly, this time I wouldn't start at my top and bottom one. The trend line pretty much is about here, isn't it? And you guys see why I chose that. This, roughly, the amount down here is roughly similar to the amount up here. Now, am I going to be crazy about this and say to you, oh, it's not exactly the way I wanted it, that's it, you fail? No. I'm going to be pretty reasonable. If you give me this, no, sorry. I'm not going to accept that. If you give me this, sorry. If you start at one of these points and you go like that, sorry. You got to give me a reasonable understanding that you realize this is about in the middle here somewhere. Okay? Does that make sense, gentlemen? And then you got to be able to follow that trend line to make a prediction. This is about 19 right here. Okay, so if I wanted to on this trend line, oh, boom. This is implying what? No, not only is it implying that it's going down, but at 19, what should the potential unemployment be? 0. Exactly. Is that an exact number? No, no. But it's a good estimate. It's a good goal. Does that make sense, y'all? May I continue? Thank you. Okay, now let's put it all together here, guys. Let's put it all together. In fact, let me go ahead and do this. Okay, so this way we can really see it all. All right. I've got U.S. domestic air travel in April. So, first thing we're going to do, please look at what I've created here for you. This is like a mini graph paper that you have. Okay, it's a mini graph paper that you have. Title it. Title it. U.S. domestic air travel in April. Why? Because you have to tell the reader what they're reading, my friends. If you don't tell the reader what they're reading, how are they going to know? Then you have to label your X and Y axis. Remember, there's an X and Y axis. Can anyone tell me why we're not going into the negatives? Why I'm staying in the positive quadrant? Thank you. You cannot go negative miles and you can't have negative years. So it just doesn't work. So my X and Y axis, I'm going to label them. Always label time. I don't care if it's years, minutes, months, days, seconds, hours, eons, millennia. Time is always X. So in this case, it's the year. And then miles, that's the Y. So miles in billions. In billions. That's how many people fly. Okay. So now we have my title. Now we have my labels. I know my X and Y axis. And now let's go ahead and start creating the actual values. I'm going from 1996 again to 2002. So I'm going to make a little 0 here. And I am going to make a line break. And that line break, I'm going to start at 1996. Okay? Now, just so you guys can see, I'm going to skip 1 so that I can have plenty of space. Okay, but you guys should be able to do it one next to the other. If you are going to skip to space out your intervals, you better make sure that you're spacing exactly the same for each interval. Don't space out 2 for one, but then 3 for the other one, and then 4 for this one, and then 2 for that one. No, go evenly. So I'm going to say that every 2 is 1 year. So that means that every 1 unit is half a year. Does that make sense? Half a year every unit is what I'm doing here because I'm skipping 2 units. So this would be my 98. This would be my 2000, right? And actually, no, what am I doing? I'm going by 2s. I'm not even paying attention to my own words. I'm sorry. Pay attention. 97. Come on, fool. Every unit is half, not 2. 98, 99, 2000, 2001, 2002. It's going to look nicer now. It's going to be spread out, but it's all even. Everything has been calculated. We're good to go. And then in billions, I go from 37 to 41. So do you think we should use a line break on this one? No? What are your intervals going to be? Okay, if your intervals are going to be 1, are you going to start with 1 or are you going to start with 37? So then you have to have a line break, guys. You have to have a line break. Have to. And your first unit here is going to be 37. Let's go again by halves. This will be 38, 39, 40, 41, bless you, 42, and 43. Please make sure you understand everything I did there. Okay, I see some people looking. Here, let me see if I can make this easier for you. See if I can square this off. Maybe not. Okay, that's not what I wanted. I guess I didn't, oh, because I didn't hit the magic pen? Oh, I can't do magic pen with one. Okay, no, sorry, can't do it. Just look at your notes. They're on your PDFs. We're good there so far? Okay, I'm going to enlarge it again now that we already created the table, okay? So that way we can see the actual points. All right, so now, read me the points, guys. In 1996, 37. Awesome. In 1997. In 1998. In 1999. 43. 2000. 2001. And 2002. 46. Oh, should have gone a little bit more. 43, 44, 45, 46. So 2002, 46. Bam. Okay, the trend line. In this case, I would choose this is one of my anchor points, and this. In this case, I go straight up the middle. That's about in the middle. And this is a positive trend. It's a weak positive trend, but it is a positive trend. Does that make sense, y'all? Yes, sir. No, but I'm just letting you know this is a weak positive trend. A strong positive trend would have more values throughout, centralizing, showing you it's really clear that it's going up. Okay? Does that make sense, kid? Any other questions on that, gentlemen? Okay, and that's it. Now, predict how many miles passengers flew in 2008. Okay, now for this graph, it gets a little bit, just because of space, but let's go ahead and see what we can do. This will be 2003, 2004, 2005. I'm going to have to extend this out. Your graph paper is bigger than mine, so it'll be easier. This is about 2006. It's about 2007. It's about 2008. It's about 2009. So what I like to do is I like to go up here. Yeah, this is going to be way, way tall because it's way up. It's way up at an angle. There's bad numbers here. Bad numbers. Bad numbers. You know what? I'm not going to make you do it with these numbers. Let's do this instead because I got some time. Let's go ahead and do this. Let's say that I have the following. Okay, here we go. Let's say that I have the following. I don't know why this doesn't. Come on now. Oh my goodness. Okay, there we go. Okay. So let's say I have the following. Let's just say we're selling widgets. Okay, a widget is just a made-up thing. We're selling widgets, and for every widget that's sold, they put 50 cents into charity. So let's say we have charity here, okay, and let's put this money in let's say millions, okay, and widget sales also in millions. Okay? And let's just go easy numbers. Let's just go 1, 2, 3, 4, 5. And let's go, I don't know, let's say, let's go by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. And let's say that this is roughly my scatter plot. Okay? I just made up some points there. It's roughly my scatter plot. My trend line roughly is, I'll do it in blue. My trend line roughly goes like this. Okay? Now, to make a prediction, I want to know how much I'm going to put in the charity after 6, 7, 8, 9 million widgets. Well, go ahead and find your 9 million widgets. Go up and find the intersection point of the trend line, and then make a left. And it's roughly going to be about 15 here, right? So roughly you'll make 15 million. Again, these were just made up numbers, Mickey Mouse numbers. The point is learning how to find that prediction. That makes sense, guys. Thank you very much. Have a great day. I hope you learned a lot.